So following along on our work here, now we want to do some descriptive analysis of the followers and shares of all this information we have. So some things good to do first is just get the descriptive statistics of each of the main variables. And the main variables we have are followers and shares. Remember, followers is followers at posting. So the number of followers each agency had when they made a post. And the other is the shares of the post. So here I have one, I don't remember which one this is, but I want you to add here. You can use the describe method. It's very simple, one-liner, and you just show the code. Now I can actually tell which one this is because of all the high numbers. So this is definitely the followers and not the shares, because shares probably minimum would be 0 and it's much lower number. So it is the 25 percentile, 50 percentile, 75th percentile, max value, 107,000, stand mean. It's a lot of good information here. So we understand the distribution of this dimension. Now we want to understand how shares and followers have moved and changed over time. Okay, so we have data for a 2-year period. So how do the followers change over time during this COVID-19 period? Do the agencies increase in followers in general, or they decrease in followers, or did it stay the same? And what about shares? Were people sharing a lot of information in the beginning of the pandemic, in the middle of the pandemic, in the end of the pandemic? So let's take a look at that. We're going to employ this combination of functions here, which are very useful, and we've used it before. So here we're going to group by date, and we can actually identify the specific period of the date, because the date has day and month and year and even hour and so on. And we're going to aggregate by date and by month, more specific, and we're going to get the mean of shares and mean of followers. And we have applied this before, and we get the result over here. So here it just says shares, but it should be mean shares. And mean shares, so every time we have an aggregation, like an average, it has to be per something. And here's mean shares per post, and because there's the data of posts. Now also note that followers is going to be mean followers per post. And that's a little bit kind of problematic, because followers is a property of accounts and not a property of posts, even though we do have followers at posting. And so, for example, if you have one agency that has a lot of posts, their number of followers is going to be overrepresented in the data. But kind of we can forget about this for now and just focus on the procedures. So notice how we aggregated by date, and then we have these aggregate measures, average shares and followers per month. And now I'm doing something here, is just resetting the index. I'm not really sure if this is necessary, but notice that date here is the index of the data frame as the special bolded color, and then I just removed it as not the index. However, eventually I noticed that if we do data type of the date, now this new date that we created of this month, what I did for shares to make sure we have shares is numeric, and it is float, so that's good, it's decimal. And then I did for date, and I'm just getting the first item of the series, because if you just check the data type of the series, it just gives you series. But note that here, this is some kind of period object. I hadn't seen this before, but this is a period object, so it's not actual date object. Followers, the last one is good, it is float, so that's good. And then here I found this code to actually translate this period object to just a regular date object. So if you run this, and I'm just overwriting back into the same column, the same data frame, and then you should get the actual data type. Now here we create the line graph of the time series of followers over time. Notice date, the first is the x-axis, and the second item is the y-axis, and then the third parameter is the actual data frame for the plot. So if you just put plot for the PLT object, it recognizes that this is a line plot. So it already knows how to graph it. The y limit, you can play around with these limits here. There's the values on the y-axis. And note that I commented out the saving. You can put this up here, remove the comment so you can save. If you're using Google Colab, you need to put this full address here to save it in your desired folder. And then sometimes you need to save before you show. And here it's kind of very interesting because we actually do see the followers going up over time. The followers of accounts, the average followers, remember average followers of accounts, except it's going down a little bit in the beginning, end of the 2020, beginning of 2021, and then going back up. Now we can do the same thing for shares, and shares has a totally different pattern. So while the followers is going up over time, the average shares per post goes down. There's a big spike in the beginning of the pandemic, 2020, and then it starts going down after that. So we did some aggregations of shares and followers per date, per month more specifically, and we actually did some visualizations of those patterns over time. Next, we're going to be talking more about text analyses.